Yes.
Okay. Before going into the order, I would like to formally ask the same question that I asked on the email, that we would like to use the recording of this session in the live QE project as a subjective testing material. We may further encode the videos, or add some distortions into it. But the question here is that if anybody has any objection, A, recording this session, and B, using this material as a subjective testing material. I should inform that it could be that we run subjective tests using crowdsourcing methods. So it means that showing these videos to audience that we don't know, basically. Should I take this as yes or no? I don't know. Margaret, maybe you can help me with that.
I would say, since there are no objections, we will take that as agreement. And let's put a notice in the chat window. I'll handle that.
Okay. And
So-
of course, yes.
So do you want more, or maybe you can tell them more people putting on their cameras? I mean, to get more interesting part.
Yes, indeed. I was about to say that. So it will make sense, of course, to have more faces, more pictures, more videos. So feel free to turn on your cameras, as many as.
Okay. And will it be available for the whole community? Like to everyone to use it?
You mean the subjective test or this recording?
The recording, at least.
The recording is anyway. It will be like any other recording in VQEG, so it will be available.
And I will note with the recording that it's acceptable for this use. And if everyone's okay with it, I could also upload this recording to CDVL so it's more obvious that this is acceptable.
Mm-hmm.
Is this mode better?
This mode looks good. Maybe what you can do is that during the presentation you can switch between the modes, so it introduces some variability.
Okay.
Maybe so right now I can see something like 7 windows, so maybe you can change windows or switch between the modes.
Okay. Okay.
So I was sent some specification of the recording. So which format it will be recorded in by Navajit, and it's a 1080p format at 1 megabits per second and 8 frames per second. Now I see that resolution is good because this is the resolution we plan to test during in our live QE project. But I'm not so sure about the frames per second and kilobits per second, because they, to my opinion, they are a bit toward the lower side. So if there are possibilities to select higher options, Navajit, can you do that, or if there are none?
I am currently checking, but I don't think there is an option. But I'm still checking. If I can, I will let you know. So I'm checking if we can change the settings.
I see. Okay, so that's it for the recording part, and then I go to formally start the AVHD session. So we have 3 talks in the AVHD session, and if you can see my screen, then you will know the order in which I want to go for this talk. Steve, this order is okay for you? Are you prepared to give the first presentation?
Yes.
Yes. So it's about AV rate Voyager. And Steve, the floor is yours.
Exactly. So let's share my screen.
Yeah.
So you can hopefully see my screen. Can you see my screen?
Yes.
Okay, perfect. So my talk is about AVHD Voyager, and that's an online tool to conduct tests. It is open source. The code is available under the link. And this is currently planned to be a paper at MMSP, so I will submit this today. So the general idea is that we all know that it's really hard to do currently subjective testing, and that subjective testing is really a required part for quality assessment, evaluation, and research. Usually you would do just a lab-based test where you have a controlled environment based on some ITU recommendations, for example, BT 500 or P910 or 13. And the idea is using these recommendations that you have a controlled environment and that you will get really highly reliable results. However, that's not always possible. For example, either you don't have such lab rooms, or maybe such lab rooms are just not accessible, for example, because it's disallowed because of the pandemic. For this reason, crowdsourcing is an alternative approach to do this. Also, online tests, I use these phrases more or less interchangeable. It has been already done for audio, for video, or for image quality assessments. The question is, how can we do such an online test? For this reason, we developed a framework that is based on AVHD Next Generation. That is usually the tool that we use for lab-based tests. And this tool already uses web technology, and it has been used in various research articles that has been published. In a similar way, you can also do online tests with AVHD Voyager. So how does it work? So first of all, you have a client, let's say a Chrome browser or Firefox or whatever you want to have. Then you connect via the internet to a HTTPS proxy, and this proxy forwards all the requests to the instance of AVHD Voyager. And AVHD Voyager handles things like storing the data that participants entered, or the ratings or the questionnaire. And later you can export the data in the CSV file or whatever kind of format you want to have, and then you can do your typical analysis. The problem with online or crowd tests is that you can't run them as similar to a lab test. So because in a lab test, you know the hardware that is used for the playout, you know the display that is used for the playout, you know more or less you can pre-screen the participants in more detail with vision test and so on. That's why you need to adapt your test design. And our framework is also based on web technology. It uses HTML5, CSS with Bootstrap, and Docker to make the instantiation of such a test really simple. From the moment it is usable for audio, image, and video tests, or just text surveys. How does it work? So you usually start with a welcome screen. And after you have the welcome screen, you have a questionnaire that you fill out. The questionnaire data is stored in the backend database, and then you get some short instructions about what is tested. Then you may do a training phase with some training stimuli and a waiting form that is already shown. And when you are done with the training, the whole test starts in the same way. You get stimuli and you have a waiting form. And in the training phase, the ratings are not stored, while in the waiting phase, the ratings are obviously stored in the backend. And after you have finished the rating, then you get a message that the test is completed and you can fill out a feedback form. So the overall idea is that you have, similar to AVHD Next Generation, a JSON configuration file that is there for some generic setup of the system. And then you need to change some of the templates. the templates are plain HTML5 templates with a bit of automatization. What have we done so far? So we did one test about image quality with this approach. But the problem is that this was more an iterative process. So we started with previous version of the system and developed it in each of the instances of the tests. So the image quality test was a proof of concept test where we compared the results to lab tests. It had 1,400 full HD size square images with an overall size of around 200 megabyte, and each participant got 150 randomly images out of the 1,484. We used an ACR rating scheme. The test was 15 minutes in duration, and in total we had 238 participants with about 35K ratings. What we figured out with this test is, because in the test itself, I forgot to mention this, in the first step, we generate the user ID, and we also do some pre-caching of the stimuli. And in the rating part, we also store information about the size of the window. So the Chrome window, what kind of dimensions it had. And based on this, we figured out that most of our participants that we had have something like 720p to 1080p resolution. This depends a bit. You don't get the full native display resolution because you have usually this top border in the browser that you're using. And based on this, we also did a second test with video quality. There's a presentation at CureMax about this talk. And the idea in a nutshell is that we used a 540p center crop. And in the end, we also compared it to a lab test that we have conducted before, and that the participants got 30 videos out of 180 randomly. It was again ACR, and 175 participants took part with around 4,000 ratings in total. What we figured out there was that it is required to have this kind of pre-caching that we included in the system later. The last test was about spaciness of music. That's still not yet published. And the idea was just to replace a lab test. So it's really small test, only around 40 stimuli, only a couple of participants. And what we changed there was that we had multiple sliders for each stimuli, and the test was really 60 minutes. This is something that you shouldn't do in a real online crowdsourcing test because it's just too long for participants usually. And what we also included there is that in the previous instance of the test system, we stored the window size in the beginning, but here we changed it to save the window size for each stimuli, so you can later check out if the window size was changed. And we also included there that you could play a stimuli several times. That's more or less what I wanted to present. So what AVHD Voyager is about, what kind of typical instantiations we have, how the test procedure looks like, what kind of tests we have done. So the tests, I didn't introduce the test in detail. So the idea was just to show that we have done there some tests with the test system. For example, the image quality test is not yet published, so, and the other paper is still in process. And as next steps, it would be like to include other multimedia formats and extend the framework. I will show a demonstration briefly. So usually, so we have this, that's the links that you can get with the bit.ly URL in the presentation. And there's a lot of text how to set it up. But it's really, it's just that you need Docker in general, and everything else is just what you need to configure if you want to specifically adapt the test. And the test looks like this. In the beginning, it may be, if you run it on your computer, it may be a bit different because I also zoomed in now a bit that you can see it better. And you will start with the questionnaire. that you can fill out. That's nearly the same questionnaire as we have for AVHD next generation. And yes, then you get the instructions. These instructions are just as a starting point, so they are quite generic, and they also don't fit to the videos and images that are shown. So then you have here video stimuli that you need to play. The problem is the HTML5 standard is not supporting autoplay if you have audio included. So you really need a play button. But if you have only videos without audio, you could also make the stimuli automatically play. And then you can rate the quality. And here that's an image, it's just for demonstration purposes. And that was the training phase. And then you would do the same for the rating phase. That's an audio file. I think you can't hear it. And then you're done. And then you can add here some feedback. It's also possible to add here something like a payment number for a crowdsourcing platform or some email form and so on. What I also missed in the talk is that it is possible to change the rating scheme. So it's what you saw now is ACR, but you could also use something like sliders or just labeling tasks. I also used the system recently for labeling tasks. Yes, and yeah, there are some references here, but I will share the slides, and that's more or less everything from my side.
Thank you. Any questions? So I see Margaret raising her hand. Yes, Margaret, go ahead.
So thank you for this, Steve. I've been really impressed with the previous AV rate systems, and I just want to thank you for making this available.
Yes, I also added your data set where you were referencing our system in the slide. So it's really cool that people are using our software.
Yes, Lucian.
Thank you very much for making it available. And I have just a quick question. The questions can be on a separate site and just cover the whole. To cover the whole screen with the video and then like a separate.
Yeah, that's possible. Yeah, the idea was that we have a quite generic, simplified set of templates. But making there the video, if the video is finished, you can get a JavaScript event, and then you could just move the rating on top. That's not a big deal. We did something like this in the past with AVHD Next Generation, but I'm open for feature requests. So just go to the GitHub page if you have a specific test, and then we will together find out a solution to do it properly.
Perfect. Thank you very much. And the second question is this test, this preliminary test with images, are the scores available? Like
they would be available if I've published the paper. So
okay.
that's a long going journal paper writing thing going on, and you know how journal paper writing is. So
yes. Okay. Thank you very much.
So next in line is Lohik.
Yeah, sorry, just a quick one. I think on a certain slide, you mentioned the fact that you compare the result of 10 with your platform, with your framework, with those of 10 in the lab, right? Am I wrong? Or did I understood wrongly? Or?
Yeah, we did see, so for the image quality test, we compared with lab tests. With the results, and for the video quality test, we compared it with lab test.
I was really interested on what type of correlation you got, and just to understand.
96, 94.
Oh, well,
that's nearly like doing the same lab test in a different lab. So
yeah, thank you.
Okay, so these were the questions. So thank you very much, Steve, for the nice presentation. So let's go to the next presentation. Okay, so this I will be presenting. So it's Opticom's model performance results in the Peanuts Phase 2 project. So let me bring up the report. How can I do that? So okay. Can you see my screen now?
Not yet. Still seeing faces instead of your screen.
Now?
Yes, now I can see your screen.
Yeah, okay. Okay, so as I have, while introducing AVHD, I gave a short description of AVHD Peanuts Phase 2 project. This project was a joint collaboration between AVHD and Study Group 12, question 14 in ITU. And the aim of the project was to develop video quality models for adaptive streaming applications. And so it has two types of model. One were short models, which were validated on 6 to 9 second or sometimes at 10-second video length. So these were video only models, short term quality, where the impairments were compression impairments. So you have scaling there, you have bitrate reduction there, you have frame rate reduction there, things like that. And then you had the long quality models where the aim was to measure the quality of video session of up to 5 minutes. So this was a short description of what this project was about. The project has already been concluded, and now 3 standards came out of this project: P.1204.3, P.1204.4, and P.1204.5. So these are 3 standards which came out of this project. Although there were many other model categories. So these models that are standardized are one bitstream model, one reduced reference model, and the third one is a hybrid no reference model. But in general, there were 10 different categories in which the models were submitted. I believe the total number of submitted models was 35 models in the competition. And due to very strict requirements, there were only 5 model categories which were at that time decided to have sufficient performance to be considered for standardization. Out of these 5, 3 model categories are already standardized in P1204 series of standard. So we have from the Q14 side, we have submitted a project report to VQEG, and you can find it in the list of files of the last meeting. And that report actually gave a very nice overview of the performance of those models which were standardized. Now, that, to our opinion, is one outcome or one set of analysis that came out of the project. It's a bit restrictive because only 3 models results are presented, in that VQEG report, although the project had submitted so many more models, which of course were not successful in, if you think it in terms of they were not available, or they were not considered for standardization, but definitely they have some very good research results that we achieved there. But what we decided then is that it's up to each proponent to create a report to VQEG in which the proponent can disclose the model performance of its own model. So that report actually is exactly that. It describes the model performance of the models which were submitted by Opticom. So let me go into the details of this report. This abstract essentially describes nothing more than what I have already described, is that the short models in the project, they were validated using 26 databases. 13 of these 26 databases were known to the model at the time of submission. So these were 13 training databases, and 13 of these databases were developed after the models were frozen on an ITU server. And so it was not allowed to change. So these databases were completely unknown to the model. And for long databases, in total, we had 6 long databases. 2 of these long databases were known to the model at the time of model submission, and 4 of them were unknown to the model. Okay. So this introduction describes a bit about the background of this project and when actually we had validated all these models. I believe it was, yes, it was December 2019 in Geneva that we finally managed to achieve the 3 standards that came out of this activity. And so in this section 3, I'm going into the details of the model inputs and model output. So in total, Opticom submitted 6 models. 2 of these models were pure parametric models. So parametric models are models where the parameters of the bit streams are the input to the model. So the first model category was bit stream mode 0, which takes into account 7 input parameters. These are video encoder, which can be either H.264 or H.265 or VP9. Encoded resolution. So these encoded resolution can go from 240p all the way up to the UHD resolution. Encoded bit rates. This is a high range of 90 kilobits per second, which is really meant for small screens, all the way up to 20 megabits per second, which is meant for TV screens. Frame rate is varied from 50 to 60 FPS. Video encoder profile, which is an optional parameter, and we have tested different displays here. So mainly 2 types of displays: the small ones, which are tablet and smartphone, and bigger ones, which are PC monitor. And in case of tablet and mobile, we went up to the resolution of 1440p, mainly because there were no mobile or tablets available at that time which could display Ultra HD 4K resolution, basically. So this bitstream mode 0 model takes into account these 7 inputs. Bitstream mode 1, which is the second type of the parametric model, takes into account all the input of mode 0 plus additional input of frame types and frame size. So frame types is like encoded video. Bitstream will have iframe or non-iframe. So we didn't differentiate between P frames and B frames or bidirectional frames or whatever. We call them non. And each frame has its size in bytes. So this was the additional input to mode 1 type of parametric models. The third category was hybrid no reference mode 0 model. That was essentially mode 0 model like in section 3.1, but additionally it had the pixel information of the degraded video to make it hybrid no reference model. And similarly in section 3.4 is the hybrid no reference mode 1, which is actually the variation of hybrid model directly derived from bitstream mode 1 type of parametric model. So you have the model in section 3.2, and then additionally you give the pixel information that would create hybrid no reference mode 1 type of model. The fifth category is for which Opticom submitted the model is pixel-based full reference model. It's a well-known category. You give original sequence and the degraded sequence, and and the hybrid full reference mode 0 model is that in addition to the full reference input, you give mode 0 information. All this information that is listed in section 3.1. So these were the 6 categories in which Opticom submitted the 6 candidate models, and additionally, there was this long-term integration function which integrates quality over the time of up to 5 minutes and create one session level quality. And there, for long PBSs, it was allowed to vary the quality in between the video segments, so to make it look like a real adaptive streaming scenario where, due to network constraints or due to players switching between different qualities, you see adaptivity of the quality. And additionally, you can also see some rebuffering issues or initial loading, and so these were part of the testing. So to measure quality in the long-term sense, up to 5 minutes, the model need to rate rebuffering, it need to rate the initial loading, and it need to rate this variation in quality. One thing I would like to point out here is that for the parametric models, we did not have any long-term evaluation. It was only for the pixel-based and for the hybrid models that we were to do the long-term, long database evaluation. Okay, for model output, as I said, for the short databases, the model was supposed to produce one number quality score between the range of 1 to 5, and that was to be validated against the subjective MOS. And for pixel-based and hybrid model, it was not only this one number on a shorter scale, but also one number on this longer scale where these delivery-related KPIs were also assessed. Okay, so I now go into the model description of Opticom's model. I try to keep very high level here. If you are interested in more details, of course, I can provide that. And some of these details are already part of the standard, and we have recently published a IEEE Access paper, so you can find the implementation details or model specific details there also. So just to go a bit in detail, so at the core, the model, the hybrid no reference model, I try to present this as the first one because this is the most complex category, and then I try to derive lesser categories from this category by removing features or by keeping some variability with a constant number or something like that. So to build a scalable model, which given the input can be more complex or simple depending upon what kind of input you give it. So at the core, it is basically a sigmoidal logistical-like function which is described by this equation. If you ignore the numerator, then you see it is exactly a logistic function, and I added this additional numerator to basically add a higher decay towards lower values, where x actually is a feature derived from the bit rate. And A, B, C, and D, these are constants. And now the trick is that I make these constants A, B, C, D further functions of other parameters. Parameters like frame rate, parameters like resolution, or parameters like content complexity. So you can imagine that this is this logistic-like function. This shifts on the side, or the decay rate changes, or the saturation point adapts based upon how much is the frame rate, how much is the encoded resolution, or how much is the content complexity. Just to give a brief detail of the model. Anyways, so and then there is this content complexity related element. I will not go into the detail. Actually, I had planned a presentation for this VQEG, which unfortunately I couldn't give because the research work there is not complete. So, but I think you can refer to our IEEE Access paper to find a bit about this very interesting content complexity feature, which actually uses a codec to give, instead of, so normally the content complexity is measured using SI or TI, but here we use the codec as a tool to measure the content complexity of the scene. And like I said before, now you start removing things from this slightly complex model, and then you can derive other type of model. For example, bitstream mode 0 doesn't allow any content characterization, so you can remove the content complexity feature, and then it will become your bitstream mode 0 model. If you replace this content complexity feature with another type of content complexity feature, which is derived from the frame sizes and frame types, then it will become a bitstream mode 1 complex model. And similarly, hybrid node reference mode 1 also can be built in a similar way. For the full reference model, there actually it was our legacy Opticom's legacy PVQ model, which was part of different standards. And so previously it was standardized for SD and HD quality, and this time around we have retrained it and added features, Ultra HD features to make it our candidate model. And for hybrid full reference mode 0 model, it was the additional parametric information that we used to make our prediction, make the prediction of PVQ even more accurate. Okay, so now about the model performance. The model performance was judged on the RMSE, so root mean square error. So you have to compute the per database RMSE, and then you have to aggregate these per database RMSE into an aggregated RMSE, and we used a weighting, different weightings to aggregate RMSE values. We gave 0.1 weight to all the databases which were known to the model at the time of submission, or they were training databases, and we gave 0.9 weight to the databases which were unknown to the model. It makes sense because you want a model to perform on completely unknown conditions. So that's why a higher weight to the unknown databases. And this table actually presents the per database RMSE values for all 6 submitted models. And you see that as the complexity from left to right increases in general, not a thumb rule, but in general, the RMSE should go lower. because the model is more complex. It has more input data, so it should produce more accurate prediction. This is the same thing, but now for validation databases. And so these are the numbers in table 3 and table 4. These are the average RMSE numbers where we have taken into account this weighting to compute the aggregated average. Okay. So additionally, I have reported the Pearson correlation values for the training set and for the validation set. You see sometimes you do not have number in some of the boxes, and these are the cases which were not validated. So as I said that for parametric models, the long databases were not tested. And so then I have in section 5.4 detailed some of the scatter plots, which will be interesting for researchers in this group. So what I did is that I couldn't present the scatter plots of all the databases because there are a lot of scatter plots. So what I did is that I picked a database which has where a certain model, the simplest of the model, bitstream mode 01, bitstream mode 0 model performed the best, and I picked a median database where it performed, in the middle, and then one difficult database where it performs, let's say the RMSE value is high. So I tried to pick 3 representative databases from this pool of 26 databases to show the scatter. So this database 7. This one was the one where the RMSE values in general were quite low, and you see that the scatter plots look quite tight. In general, you see again the same thing, that as you go towards complex models, you see that the spread of the values around this unity line is becoming tighter and tighter in general. That doesn't hold always, and I don't know why it should hold, but it's probably goes into the details of how these models are trained or how much variation it can, it can confront. Then this second database, database 11, this was a median database, so their RMSE values are in general higher than the one above. But again, as you go down to more complex models, hybrid node reference or full reference model, it becomes better. And then this database, their things start looking a bit ugly. The prediction is not that accurate. It was a difficult database, probably due to the different type of content. And sometimes the balance of the database is not high. So, you cannot fully, there is some noise also in the subjective values also. And so in general, that poses a different kind of difficulty to the model. Anyways. This section actually, it's details about what was the qualification criteria for different models. So in general, there was a statistical criteria on which the models were checked. So we didn't go matching the exact the absolute RMSE values, because that can be different for different models. So what we did is that we created a range of values where the lower number in that range is the best performing model in a certain model category. And then we created a certain significance interval with respect to that RMSE, and any model that has its RMSE falling in that range is considered statistically equivalent. But also another aspect was that you don't want to have these ranges for different model categories be overlapping, because if these ranges are overlapping, then it means that the model, these different type of models are also statistically equivalent in performance. So we only consider those models for standardization where these performance ranges are completely non-overlapping. That is, that a higher complexity model yields significantly better performance than its than the lower complexity model. And so here in this section, I have copied basically information that was already presented in the VQEG meeting of December 2019, if I'm not wrong. And so here, actually, you see the model performance of Opticom model with respect to best models in the competitions. Yeah. So and you see these lower thresholds, and you see the upper thresholds. Okay. And similarly, another table which is for short plus long evaluation. Yeah. There are some sections of this table which we couldn't write down here because the NDA stops us from publishing the results of other parties. So we try to publish only the results which details Opticom's model performance, and so no performance of any other proponent is disclosed. So just to the conclusion, so we Opticom have submitted models in 6 model categories. So 2 parametric models, 3 hybrid models, and 1 pixel-based model. And the 3 models, bitstream mode 0, bitstream mode 1, and hybrid no reference mode 0, these were part of the winning groups. So winning groups are the models which perform significantly better than other models, so they could have been considered for the standardization. Out of these 3 categories, only hybrid no reference mode 0, it made it to the standard P.1204.5 is the standard, while the other categories, bitstream mode 0 and bitstream mode 1, there were multiple winners, so we couldn't find a consensus to build a joint model on that. So the standardization activity on those models didn't go on any further. So that's it for my presentation. If you have any questions, feel free to ask.
I have a question.
Sure, go ahead.
Now, have you done any assessment in terms of the computational horsepower it takes for your implementation? In other words, can it run real time? And what is the hardware requirements for that?
Okay, so we did, so this assessment of complexity was not part of the competition. So there was no formal validation of the complexity as you asked for it. But speaking for Opticom's model, except the full reference model and the hybrid full reference model, other models can run in real time. So 4 out of these 6 models can run in real time.
So the non-reference one can run real time.
Yes.
And this would be off of a 6-core, an 8-core Pentium, an Intel like an i7.
We didn't test on that, but if you even look at the computational complexity from, these are essentially set of formulas that are mapping different features to the quality score, except only in the hybrid no reference, it is this complexity feature that is a bit more complex. So looking at the pure formula, I see it shouldn't be any problematic to not run it in real time.
Right, so it should run, and based on what I saw, the complexity in terms of running seems to be reasonable. I was just wondering, have you guys done any, like, you know, when you run a file, how long does it take, and given any assessment? But you're saying the 4 out of 6 generally should probably be comfortably running on real time.
Yes. So for the short case, for example, we were measuring complexity. We were measuring quality of let's say on average 7-second videos, and so the running of the model takes lesser than the length of the video. So so then it's a very good indicator that it can be run real time.
Thanks. Thank you.
I see Chris raising his hand. Yes.
Yes, thank you, Shahid. One comment to the complexity. So the bitstream models, the plain bitstream models, they are so low complex, they should easily run on any microcontroller essentially today. So it's virtually nothing. The story is different, of course, with a hybrid no reference because of the complexity metric, but even that should run in real time easy on any PC today.
Thanks.
Oh.
Okay. I'm just adding a comment here, but we implement on FPGAs. Has there been any understanding of how difficult it is to realize on a hardware FPGA?
Well, we did not look into that yet, mainly because there was no need for it and nobody asked for it so far. But of course, if it's interesting for you to provide such an implementation, we can talk about it.
Yes, we would. It looks like the complexity. Now, which version, which model you said that probably can run on a controller? Is that one of the no references or the other ones?
Yes, the bitstream mode 0 and bitstream mode 1.
0 bitstream. That's a no reference one.
Correct.
Very interesting. Okay, that could be something that we would be very interested in considering. Something we could possibly talk offline.
Yep.
Thank you.
So any more questions or comments? Okay, hearing none, I need to go now to the third presentation in the list. Can you see my screen?
Yes.
Yeah. Okay, so this presentation is going to be about an overview and a status update of our newly started project, which is about measuring video quality in live streaming applications. And so I, together with Rohit and Silvio, will giving this overview and hoping to start basically a discussion because we still have many questions unanswered to finalize the planning phase of the project. And so I would like to use this time to start this discussion. So let me now share my screen. So just a moment. Okay. Can you see my screen now? Hello?
Yes.
Okay.
Yes.
Okay. In the last VQEG meeting, Rohit came up with a short proposal to start working for quality models for live video streaming applications. At that time, we thought it's a good idea, mainly because there are not many activities targeting this area in VQEG. So we started with, let's say, a feasibility phase where we start, talking about it and write some short proposal. And so on the way, in monthly AVHD calls, we try to develop a proposal. And so now we are already working towards the test plan. Let me, for those of you who haven't been part of these discussions, we have created a deck of slides. So, it will help you grasp the idea, what we want to achieve here. So this will be the outline I will be following. The goal of this project is to measure the quality of experience for audience of live media streaming sessions. So in general, you can divide live video streaming services into two categories. You can call them broadcast applications, or you can call them conversational applications. And so the idea is to measure the QoE of both of these different. In general, many different factors can affect the quality of experience. It can be the compression that is introduced by these real-time encoders or the network or playback devices. And eventually the idea is to create machine learned models to predict the quality. But of course, for that we need data. And so the first phase of this project will all be about gathering this data, which we believe that there's in this domain there's a big lack of data. So most likely we need to produce it, but also we are open to get data if it is already available, either open source or proprietary. So going back to the scope, as I mentioned before, you can divide the live streaming application to broad categories. So broadcast application, these are one-to-many applications where you have one single broadcaster or streamer, if you would like to call it that, and that is, sourcing the content, and there may be a number of viewers out there watching this streams. It can be transmitted both on reliable medium or unreliable medium, so TCP or UDP. So both protocols are will be considered, and the examples of today's are Facebook Live, Twitch, or YouTube Live, or you can count many others also. In the conversational sense, it can be mainly these very low delay applications. Microsoft Teams is one of them. So you have instead of one streamer, you have a number of streamers there sending the media content, and so it's more interactive. And so there actually it's I think TCP is not an option, so it's all due to its delay requirements. It's UDP. Examples are self-explanatory. What we are not interested in, at least at this stage, is to address the interactivity issues, because these real-time applications, they of course have another aspect to them, is that how responsive are these applications, and that part actually correlates with the interactivity. Mainly why we are not interested in this aspect right now is already the scope of the project is too broad, and so we do not want to include interactivity as our focus of research. And the second problem is that that interactive testing is a different type of subjective testing, which I think right now we do not even have standards for that, and it's more complex to do that kind of testing. I believe there are some efforts already underway where interactivity is considered, maybe not in the in this broader scope sense that we are dealing here, but in a limited scope. Like one example I recall is the ITU BBQ CG work item, which deals with interactivity for gaming applications. So content categories. So coming from this definition of broadcast and conversational, you can divide the content categories into premium and user generated, where the premium content is this very high quality produced content for broadcast application. It can be sports, concerts, news performance, news or performances. And for the user generated content, you can have the broadcast, which can be gaming or musical videos, or then in the user generated category you can have the conversational content. And in the start of the session, actually I asked for your permission to record this session so we can use this content to create test conditions for our conversational content. How we see the impairments for the live QoE, we see them as in three different domains: audio, video, and audiovisual. I, being somebody coming from mainly from the video domain, I have to hand over here the floor to Rohit or to Silvio to go over this slide where we have detailed the audio related distortions. Rohit, can you take on that?
Yeah, I can speak for a few minutes. Yeah, good morning and good evening, everybody. So like Shahid alluded to, just taking a step back, we are in very early days of this project and we feel this is a big endeavor. And we've tried to break this problem into parts. And one of the dimensions is thinking about the impact of audio on the quality of experience of a live streaming audience. So within this context, at a very high level, I wouldn't go into like line by line details here, but at a very high level, the different dimensions could be an aspect of compression. So there is some line items written over there in terms of what we might be interested in terms of gathering audio data. Other aspect could be the kind of role network plays. So in live streaming, we are very sensitive to the network situations. I think there was an excellent presentation earlier today, I think by GMA University and Carnation, I believe. So they covered all these topics very well. So yeah, in some sense, I'm just reinforcing what they said. So network impairments matter a lot. They typically manifest as either losses in packets that were transmitted or as jitter in terms of arrival of packets. And depending on the transport, that could manifest as latency. That would be the TCP case, or actual loss. That would be the UDP case. And our playback pipelines, they vary from application to application. There are scenarios when there need not be any concealment of what was lost. There could be scenarios when there is concealment and there is improvisation, as in if you are in a reliable transport and you encounter latency, then after all the packets have been received, as you might have seen, some of the applications play back the media at a very fast pace to catch up. So that could be another category we look into. What also happens in live streaming setups, more on the conversational side, but sometimes in the one-to-many setting also, wherein there is a notion of co-hosting, like multiple streamers broadcasting to an audience. There could be like things like echo and reverb depending upon the setup. So those could be interesting things to look into. Also, packet loss results in things like popping of audio, for example. So that's another type of artifact that we would like to consider. In terms of the parameter space that we could play with, three broad dimensions here, codecs, bit rates, and sample rates. So we just to have just to have a place where we can get started, we propose we consider codecs like AAC, MP3, and Opus. Some of the live streaming softwares, they tend to prefer using AAC, so that's why it's there. Opus is fairly common in conversational setups. WebRTC uses that as a preferable codec, for example. The range of bit rates that I propose here, I think 128 kilobits per second could be on the higher side. 64 kilobits per second is a pretty common sweet spot for live streaming setups. And in terms of sample rates, I think up to 44.1 or 48 kilohertz could be interesting for us, I think. So like these might be the broad categories of clips that we might want to create, either by finding them from real world data sets, or by creating simulated distortions, and we hopefully those result in realistic artifacts that we encounter in realistic situations. So with that, I'll hand over the podium back to Shahid.
Okay. Thanks, Rohit. So the second domain is video-related impairments, where we deal with compression, scaling, so frame rate dropping, etc., frame rate reduction. And so since in UDP cases, we may have a situation where the packets are lost on the way, so considering packet losses where on the playback side they are not concealed, or they are concealed, and in the live case sometimes the freeze happens, and most often they happen with content skipping. So these different type of aspects they will be considered, and sometimes due to the delay in packet arrivals, the packets are, even though they arrived at the end side, they are not useful and they have to be dropped, and what kind of distortion they can create on the playback side, these all will be considered. So the general parameter space is we consider different codecs. I'm not sure these three are the list is complete. I believe we probably have to include AV1 there. I'm not really sure what codecs are actually in deployment right now, but we try to cover that space. We had been contemplating about going to Ultra HD resolution, but that I think is not a realistic thing to do. It is very difficult to acquire content which is 4K and which still, spreads these different content categories that I earlier presented in this tree diagram. And B, it's not always the case that Ultra HD is used for broadcast and conversational application. For example, for conversational application, it's hardly 720p, let alone that it goes 1080p. And so we thought that maybe and for the live entertainment case, it could be that you sometimes have 4K content for live. So what we thought is that maybe at this stage, 1080p is a good common denominator across different live applications. So we will stay with 1080p. The content is easy to acquire. And so we want to test different type of displays. So mobile, tablet, PC monitor, and TV. Mind you that not all displays will be considered for all different type of applications. For example, I would say if you go for conversational, then you do not consider TV, you consider PC monitor, because many live conferences, conferences are happening on PC monitors and on mobiles, certainly. If you go towards the premium content, then you for sure will go for TV and maybe not for PC monitor, because on TV, these contents are most watched. So basically, we need to pierce this matrix in a very clever way to comply to whatever is used right now. And the third domain is audiovisual. So we call them multimedia impairments, where we deal with the synchronization issues between audio and video. Like you have lip sync issues due to different kind of delays. Audio packets and video packets are going through. So at the end of the day, you see the two stream being slightly misaligned or missynchronized. You sometimes have freezes in audio or video due to one stream being present, one stream being not present, while other can continue running instead of freezing the complete play out, because that would certainly yields a lower video quality experience. So one or the other stream is stopped, so that is also one kind of multimedia impairment. Or Rohit, I don't know what is the difference between second and third.
Oh, one category is where all the media stop. The other category is where one of the media is flowing.
Okay, yeah. So the two variation of the scenario that I presented. Either you stop everything, or either you let whatever is available, and the other one you froze. Okay, so these are the different range of different impairments that we are considering. Of course, these lists that we present here are not exhaustive, and if you are aware of some impairments that are not listed here, please inform us, and we can discuss about it, and we can add it into the list. This is a complex slide, and probably I don't want to go into the details right now. It's about model specifications, that what kind of models we want to build out of this data. It is at this point in time, I think we are so many other uncertainties and unknowns that probably we cannot go into the detail of defining model interfaces. But here are the 4 categories what we think can be feasible, where the first type is the signal-based model, where you have decoded audio and video frames available, and then you can use them to produce the quality score. And the second one is that you have audio and video packets are available, and if you want to, you can decode them. So this yields something like bitstream no reference models. And the third category is when you have you have access to audio and video packets. Okay, so in the second category, you are only allowed to decode the audio packets, and third category, you can decode both audio and video packets. And in the fourth category, you basically work with the header information because the encryption or because of other reason, you do not have access to the payloads of the packet. So the only thing you can work with is a very coarse header information. But anyways, this information is, I think it's too early to pin down this model specification. So we probably will, after we have created the data and we see that this data represents the actual live streaming experience, then probably we can talk about the model specifications. So we have reached some decisions during the monthly calls, and so we would like to, keep these decisions fixed and not change them unless there is a very good reason to do that, because these are the results of very extensive discussion. So we said that we will test video clips of 20 to 30 seconds. So this duration is generally a bit longer than the 10-second clips that we have been testing in VQEG and in IQ also, for testing the short quality videos, so short duration videos. And so in case we find out that 20 to 30 seconds is not enough because there is a particular type of impairment that cannot be addressed in this duration, like for example, audio video sync issues, and we may go a bit higher than this duration and go to 60 seconds. And so the aim is to test the impairments in their individual sense, not to mix different impairments in a single video clip. And so we also are not interested to integrate quality over time. So long-term integration is out of scope of this project. The aim is to find the perceptual impact of impairments in their individual sense. We said that we will test using 5-point ACR scale with hidden reference. And so there were discussions about why don't you use continuous rating, where the user is given some kind of a access to rate while he or she is watching the video. So there were fair points against that, and we said that since we want to test impairments individually, and the quality is intended not to vary over the duration of video, it makes sense to stay with the discrete quality testing. And so 5-point ACR hidden reference because the content will involve user-generated content, most often with camera impairments. So it makes sense to have the scores for the reference itself. So to see how is the quality of the unimpaired video. I explained that due to content availability reasons, we are staying with 1080p and 60 FPS. Maybe 60 FPS for the gaming application is too low, and I think the VQEG fellows who are available in this call might want to comment on that part. And so for us right now, for the generation of test conditions, we are completely open to simulate distortions where you create some kind of a JSON file to write down impairments and simulate them using a processing chain, or you can use real network traces and capture the playback to get more real world conditions. So now the thing I mentioned in the start is that we would like to open the floor for some discussion, and these 3 questions basically I want to put to start with this discussion is that we can we can acquire user generated content. I think that's relatively easy, but the premium content is difficult to acquire. And in the previous projects, like in Peanuts Phase 2, we had some of the companies did made available some content, but there is also the problem that VOD content is sometimes different than the live content. In the live content, you have not so many scene cuts and the same camera angle for a longer duration. So the question is, can we use, in case the premium content for live is not available in good quantity, can we do some kind of a content characterization of our VOD content and use that in our project for simulating live conditions? And the second question is that are there already network traces or media available that can be used in this project? And as an extension of this point is that what can actually be used from other STOs or from other projects within VQEG, or if you are aware of any projects outside VQEG which is working with the live stream. So what can be used? So I leave the floor here with questions. So you asking the question and probably also starting the discussion about these aspects. Thank you very much. Any questions? Shall, how much time we have scheduled for this session? So I just want to get how much time we have.
So this discussion is scheduled until we close. So take as much or as little time as you need.
Okay. So waiting for your comments or questions or any other input to the slides. Or are we 3 are the only one in this call? Me, Rohit, and Cheryl, and Margaret. Margaret, I hear.
I'm here as well.
Okay. Now
I see Werner has raised his hand.
Yes. Yes, Werner, go ahead.
Hi. Yeah, thanks for presenting this. I mean, while we're at the topic of discussing open questions, I think one question that came to my mind is, in terms of testing this, and in terms of getting the right mindset for the users who will be participating in the test, I noticed that there's like an increasing discrepancy between what people are expecting and what they're experiencing in real life versus the kind of horrible scenarios that we create for them in the lab or in crowd tests, right? I mean, we did some measurements where we saw that really only a tiny fraction of video streams are affected by stalling. And this is for video on demand, of course. Whereas, in these types of tests we did for Peanuts, there was a lot of stalling, and people maybe would have even been surprised to see that much stalling. And so I wonder how much the ratings given by people in this scenario would reflect their real life experience. And I'm not sure where I want to go with this, but maybe we could even use the fact that we have like a big streaming company here. Like maybe we could find a way to align whatever subjective ratings we get from the subjective tests with maybe ratings from the real world or ratings from the real service, where we have the conditions from real life, and then can like find out what is the linear shift between what people told us in the lab versus what they would say in a real life scenario. Thanks.
Good point. So next in line is Yanis.
Thank you, Sahid, and I hope I can be seen. So thanks, Werner, for bringing up actually an excellent topic. I'll spend just a few moments to comment on the first portion, which has to do with VOD. I think it's many people may know already an article that eventually got published at Transactions for Image Processing, IEEE, where we actually presented, this was part of the work that I did when I was at Netflix, where we presented essentially one potential model to do end-to-end quality prediction. Again, this was for VOD. And even back then, when we were preparing the stimuli, we were debating about this exact topic, right? So the data, the internal data, pointed it out that for example, the occurrence of a stall is an extremely rare phenomenon nowadays, right? So it either happens whenever you have like total loss of connectivity, or the ABR algorithms themselves are too smart and they are more aggressive into switching downs to avoid stalls. So Werner, I actually had exactly the same existential problem back then. Should we really be testing on what is currently being, let me use the word, deployed, right? Should, in other words, the stimuli represent reality, or should it be more generic to cover the cases where, for example, ABR algorithms could go tomorrow? And eventually we went down the path of creating perhaps artificially bad stimuli, which by no means reflect, for example, let me say, back then the Netflix experience or any other streaming service today. Because again, the idea was for a model to be more open rather than be constrained. So, but to your point, one of the topics that we had discussed, I don't remember which call was that, Sahid, maybe the last one or the one before that, I had surfaced the idea of actually using a practical service, Twitch, Facebook, YouTube, and others, who I think, first of all, they are free, right? Anyone can put their content, and you don't need to have anything. And then capture on the other side. And in this case, you have more realistic signals that would be, by definition, reflective of reality. But I think that the idea to cover single impairments, which I see that being mentioned, is sort of, it's contradicting, right? Either you go with multiple distortions and allow whatever comes out of a pipeline, or you choose single distortions for, let me use the word simplicity, and the ability to get better modeling. But in summary, I would say that a mix of the two is the way that I'm thinking today makes more sense. If nothing else, because you want to make sure that the amount of, say, stalling, the duration of the stalls, the resolutions, the bit rates, all these parameters that are currently going to be chosen, let me use the word ad hoc, can be chosen to match what is today's ecosystem. So Sahid and Werner, I think we can all work together to at least provide enough feedback on the specific choices that are being made, right? Which codecs, which resolutions, which bitrate, or even which, let me use the word, encoding recipes will be used to produce PVSs before the subjective testing goes on. These are my thoughts. Thank you.
One small comment, I guess, I could offer is that live streaming setups tend to be more constrained than VOD, for example, especially if you consider the content origination side of it, depending upon your network conditions, if you're on your cell phone or you're on some sort of Wi-Fi, odds of encountering impairments are high, and they do translate to artifacts on the viewer side. The other angle over there is as you try to make your live streaming systems lower and lower latency, your tolerance for network impairments decreases. And for example, as a playback engine, if the amount of data that I can buffer, like my ability to smooth out, if that's not a lot, then that also translates to higher observation of artifacts. So, so in that sense, at least relative to the video on demand situation, we could expect that in real world, there is a bigger role of all of these impairments in a live streaming setup. I'm assuming in the call today, most of us, many of us are probably coming through stable Wi-Fi or I guess wired internet. But if you were to come through a mobile environment, things could be a bit different.
Werner, yes, go ahead, please.
Yeah, I think, by all means, I think we should definitely try to include as many different conditions as possible, and also have them be critical and really, try to find out which are the weak spots and how do they affect customer perception. I think this can be accommodated, if we already now at this stage take into account how would we characterize the accuracy of the model in different consumption contexts, maybe. So maybe we already plan to evaluate the results in real life, or by having some providers, if there are resources to do so, provide feedback from their real users about known conditions, right? I mean, you could, in any given random Twitch stream, pop up a window and then ask the user for the rating, right? And then the conditions under which that stream has been served, and can compare this with what the model would have predicted. And if you do this on a large enough scale, you would know like how well the model would perform. And it wouldn't mean that the model itself is bad. I mean, we know it was maybe developed under a different context. And it anyway cannot be developed if all is rosy, right? So we need critical conditions. But that, I think, would be a way, if we already think about how to do that now, or at least make that part of the evaluation plan, I think that would be worthwhile.
Yes, Lucian.
I think it's a very nice idea, if possible, because I understand that also this would be very, maybe not very, but to some extent hard for the users. If the pop-ups from time to time is jumping off, not necessarily they like it, and then this is difficult from this let's say psychological factor point of view. How much the answer is I'm annoyed by yet another question, how much it's really about quality. But what I wanted to point out is that there's a yet another, let's say, level of that. So that the people are not actually focusing on quality. They're focusing on the content that is interesting for them. So asking about the quality of a model or about the quality of a stream, in my opinion, we actually have kind of two questions to answer. So is the quality good enough that people really don't care? If we change it slightly, they will have a notice. Or are we in this interesting quality zone where really the changes got an impact on the user? Yeah. So this would be like a two-stage model, very different than we normally do it. And in my opinion, to some extent, this is kind of a future of the quality evaluation, where we go beyond just pixel quality, which is continuous value for sure, more into this ecologically valid quality, where as long as you are not asking about the quality, people will never tell about quality anything because they really don't see it. Yeah, the service is just working for them. And there is a certain quality for which the quality start to be visible for users. Thank you.
Next in line is Yanis.
And Lucian, I noticed that your video right now, at least to me, made perfect testing material. You had some audio artifacts, some AV sync. So, and I don't know how good my video and audio gets through, guys, but this is good stuff. So, Lucian, I think you are hinting, the way I'm understanding, to changing essentially the scale, allow me to say, the way I see it, right? Because as part of the ACR methodology, the underlying assumption about ACR methodology is that people will be asked for quality, right? So what we are saying now is that we're going to be having sort of a binary questionnaire first. Did you notice anything about quality, or you didn't notice anything about quality, right? If you did notice, how bad was it, A, B, C? So it is similar, in other words, to the work that has been done, in my opinion, in again using a different context, was VOD by Patrick's group on the annoyance and acceptability, scale. So one can actually consider, and I also see our good friend Lucas raising his hands, who probably has something more to say about this, a modification to the 5-scale ACR that is currently being proposed, right? We can rename it however we want. We can just call it 3-scale, as it was done by Patrick back then. Was it annoying, right? Or was it acceptable? Yes, no. If it was not acceptable, was it annoying, right? And then you have these 3 scales, because it is, I think, in general perceived that even if we produce a 5-scale ACR today, the correlation of 5-scale ACR with the user truly perception of quality in a subsequent practical streaming service is definitely not linear. There are multiple thresholds there. One where people don't care, as you say, about quality. And allow me to say another threshold at the bottom, where people are so annoyed that they don't care if it's a 1 or a 2, right? They just stop watching. So in very, very high, in very broad sense, maybe it's time for us to identify that there is perhaps a middle linear range and 2 saturation points, and modify our classic 5-scale ACR. These are my thoughts, but I'll leave it back to the chairs.
Sorry, let me just quickly answer. So, Yanis, what I thought was actually something slightly different. So the moment you ask about quality, regardless if it's did you notice or not notice, but let me think about something super correct from this ecologically valid experiment point of view. This for me the best one is actually this from Gant University, from QMX 2012, where they described the situation. They gave people the videos with some distortions, and then they interviewed the people about the session. But they didn't ask about quality. They asked about the general session. And in some answers, there was nothing about quality, although there were clear distortions. And they had to press the people to actually get any information that there was any distortion there. So they had to really kind of tell them, but did you notice anything about this video? And then they start to speak about it, but not at the first glance. So in my opinion, this was kind of proof that actually, yeah, maybe the distortion was clearly there, but this was not important for them. Yeah, for other people it was enough important to start from there. So this is this problem of measurement in general, yeah, and this, especially in psychology, this problem is especially important, because the moment we start to ask the question, people are answering honestly the question, but still we don't know what was the real impact. I don't say I have the answer. I just wanted to clarify my thoughts.
Next in line is Lukasz.
Yeah, thank you. this is a great discussion. Thank you for bringing it up, Lucian. And I wanted actually to second this, just virtually by asking people to evaluate quality, you are changing the task. They pay more attention to the artifacts, and something that they wouldn't notice because they would be immersed in the content, can pop up and so on. There is very little you can do about it unless you really do what they did before, where you just ask them to watch the videos and then you ask about that. But this very much limits what you can actually do, right? So this is always going to be the trade-off. I wanted to touch upon other things. So what you mentioned is in this scenario, and it's also going back to the annoyance and so on. So you would say, as long as we as long as people don't notice, we're doing a good job, and this is a good indicator of quality being good. Which this doesn't capture is also that sometimes you could be, the quality itself can be a great thing for people to want to watch more, even though they do not really care that much about the content, but it looks great. It just, I don't know, the colors are great. And so there's another aspect to this whole quality evaluation, is that how much of an impact does the look of the content has on the watchability of it. So I would say that this is super interesting, super multi-layered, but I don't have an answer to like how would we even dissect it in a way that we can measure that independently. And if we just measure it all together, we may be kind of misled to think, oh, this is the factor that is causing this, whilst it's actually multiple factors that are interacting together. So yeah, I just wanted to make this comment without bringing any answer to that. Just I don't think the methodologies as we are using them today are capable of measuring this.
Yes, Margaret, go ahead, please.
Thank you. So to argue the other side, people, if you don't ask them about quality, may assume you're asking about content, because the reason you watch videos normally is for the content, not for the quality. And they may underreport opinions of quality simply because of that assumption of what you're talking about.
But in real life, they watch for the content. So as long as they don't notice the quality, it means it wasn't important. Of course, it's not so easy, because maybe they notice quality, but they think that you are asking about the content. This is super complicated for sure.
Yes, I would say rather they may note quality problems, things they're not happy with, but still assume that what you want to know about is the content. If you're designing the experiment where you ask, what do you think of the video? They may, certainly some people I talk to, they assume, well, of course you're talking about the content. And I think I saw Werner's hand go up.
Yes, thank you. Slightly tangential question or comment. I think, for this kind of model development and seeing the uses targeted and also really engineers using that model, you anyway have no choice other than conducting these kinds of tests that we've always done, like where people are primed to look for quality issues and where you want a sort of technical perspective on customer perception, because engineers will use the outcome to fine-tune certain aspects of the whole streaming pipeline. It's just a matter of contextualizing the model predictions in real life, and for that maybe you need these other kinds of ecologically valid tests.
Yes, Lucas.
I just wanted to second this, because maybe I think that Margaret's point is really well made, and essentially whenever we have an experiment, so we invite people, they try to hack it in a way like, so what is he looking for? What or she? What are they trying to do, right? So the context itself changes. It's not the same thing as they would sit down at home and watch the video, not really think about the quality unless it's really disturbing and so on. So unless it's us who always get annoyed by the quality, right? So it's sort of a different story. So I would agree with Werner that this is something that we just need to, I guess, accept in a way that by measuring it, we are distracting the like realistic scenario. However, maybe it's not a bad thing, right? Maybe people are actually paying more attention to the quality, so we get slightly lower scores than we would get in real life. But at the end of the day, we want to make this thing great for the people. So if they are happy with it under the scenario that is already constrained by the fact that they know that they are watching something for a purpose of quality testing, so maybe it's a good thing that it's actually bringing down the worst case scenario.
So our discussion till now have mainly focused on the subjective testing methodology, right? But I think we have other aspects also, like one of them I mentioned was availability of the premium content. And unless we have those, we cannot simulate our distortions to actually see if they are ecologically valid or not. Definitely what we can do is that since we have the permission of the group to record this session, and we can use that as an input to our test creation of the test conditions. So as far as I know, going forward, we only have material to test our conversational applications, right? Correct me if I am wrong.
Yeah, I guess so far we are focusing on the gathering of the conversational content.
Yeah. One question to Florence. Florence, you have given some content for our phase 2 project, and those were sports videos. I believe football, American football or soccer. So I think those should be even okay to be used in live setup. And do we need to have again a formal permission from you, or it was anyway an open source content?
It was open.
Can't hear you.
Did you hear me?
Yeah, we can hear you now.
Okay, yeah. It was open source and it was uploaded to CDVL.
Ah, okay.
Florence, did you also provide audio for it? Because I think that's one of the requirements here.
Ah, Correct. No, there was no audio, because I think when I was asking for that content, I have to check again, but I don't think there was audio.
Yeah.
I mean, it makes no harm for me asking for what duration are we looking for?
So as I mentioned, even short durations like up to 30 seconds will be really useful for us.
Yeah, I can ask again, but I can't promise anything until I get the go ahead. And it is 1080p, right?
It's 1080p, yeah.
Okay.
I want to take more like project management approach towards this project and see what we need to do next, basically. And what we have started doing is actually started making a test plan document where we will actually pin down the actual test conditions, HRCs, basically. But I believe we can maybe even at that stage create a database which can be like a representative database, and share these videos to take a feedback from you guys or from the group, that how realistic are these test conditions in view of our experience with live applications. Lucas saying, did I just kill the whole discussion? Anyway, so I do not have any further points to add to this discussion. So if there are no further comments, then probably we can end this discussion and we can take it up again in our monthly calls. And Margaret, can you inform when is the next AVHD call we have already scheduled?
Hold on, let me go look. I believe it's on the main VQEG webpage.
Yeah.
There is one quick thing that I wanted to add, Shahid.
Sure.
So
go ahead.
As Shahid indicated when he was going through the slides, we are working through the test plan document also. So all of you who are interested in this domain, please feel free to let us know, and then we can iterate together on like specifics as we come up with the test plan document. For example, like the range of conditions that we propose, if anyone has independent experience and feels that we are not covering or we are over engineering this, that would be a very good forum to interact us with.
Indeed. So let me inform when is the next call. So if you're interested in that, then you can take part.
Yes, apparently
Yes, Margaret, go ahead.
I'd forgot
Go
to put
ahead.
it on the main VQEG webpage, but I will put it there now. The next meeting is June 21st.
Okay. June 21st at 5 o'clock European time, right?
Yes.
Okay.
Yeah.
So thanks everybody, and that concludes the AVHD session. And if you have any questions about this project or about any other AVHD project, please write to me or to Silvio, who is co-chair. One point that you mentioned offline, Margaret, and probably we should bring it up here, is that I think you wanted some changes in the chairing of the AVHD project, right?
Yes, I think it might be appropriate. The current chairs of the project, if you look on the board website, Shahid, you're clearly leading discussions. But it's also Kwan and Silvio, and I was wondering if somebody more active in discussions might be appropriate, either to replace or to add.
I am not sure about Kwan. Is he still active in this project or still active in VQEG at all? If not, then certainly somebody can replace him. If he's not interested anymore. And I see the need for somebody who is more involved with live streaming services, because I myself come from mainly from VOD, and so for a better lead to this project, certainly somebody coming from that background will be beneficial.
Has anyone heard from Kwan recently? Michelle, have you?
I mean, not so much when it comes to VQEG. I mean, he had I mean, he's not completely kind of stopped following what's happening in VQEG, but then he again he doesn't seem to have much time to devote. So I wouldn't know exactly what he would answer, but it would probably be nice to ask him, of course. But then I think it probably is very good to get some more person involved, since he has been very little active recently. So
okay, let's treat those as two separate questions. Shell and I will send an email to Kwan asking if he's still interested in the topic and interested in leading these discussions. And separately, is there anyone who would be willing to join Shahid in leading this effort?
Margaret, this is Yanni. Since I'm a little bit overloaded personally, but I think that Facebook as a company has a lot of vested interest in this activity and can definitely help on both logistics and, of course, conditions. Am I assuming here, Rohit, that you are all by de facto added to the list of co-chairs in this case, or this is still up?
I have no formal title. You could consider me to be the person who supports Shahid as much as I can.
Okay. So again, let's put tentative. But again, I know I'm a little bit oversubscribed here, but I'm with the group's permission, we can take up on the next call to have maybe someone else from Facebook step up and be more, because I really want to help, but I don't think I have the bandwidth right now. But definitely there are people at Facebook that would be both willing and have more, time to allocate, because I think that the project needs people to really do the work rather than just titles. So from that point of view, you can put my name temporarily until the next call. Perhaps you can discuss another person from Facebook, if that's acceptable by the group.
That sounds good to me.
But I was thinking, there are 4, let's say, tasks in the AVHD. I mean, one could think of having at least one dedicated person per task. So maybe if we want to keep AVHD as an umbrella working group, then the chair is basically the working group for the whole working group chair for everything, and maybe I have the vice chair, one for each of the subtasks. That would then basically drive the work more or less, and in that case I would probably suggest Rohit to be vice chair for this live streaming, if that would be acceptable by him. How about that? I mean, that's because there are so many activities going on in AVHD, so I guess there need to be more people involved.
Yeah, I don't understand many of these nuances, but we can talk about it offline.
So Shahid, what do you think?
I like this approach that you proposed, Rohit. I think it's a good time because we still have time in this session, and probably will never get so many people here to get a good decision made. So taking it offline probably will not be such a good idea. So I would if there are no strong preferences, I would like to go with Shell's opinion, and we can actually integrate Facebook in there as well, because we can have for the live QE, we can have Rohit as well as one person from Facebook being the main lead, the live QE part, and we still have other activities in the AVHD, and I can of course take care of those ones also, as well as I would like to stay involved in the live QE, but not as a lead.
So will you be leading be chair for the whole AVHD, the kind of the umbrella part, or do we not having that?
That's fine. That's fine. I can do that. That essentially, being a coordinator with different project leads, right? So that's a doable job.
Okay, so the proposal is to add Rohit and Yanis on as vice chairs of AVHD, and send an email to Kwan and Silvio asking about their continued level of interest and whether we should remove them. Is that correct?
Silvio is still in the call, so I think we can directly ask him. I am pretty sure he would like to stay involved, and at least I want to have him involved because he's very knowledgeable in general.
Silvio?
Yes, hello. So I'm still here. Yes, so I wasn't very active the last weeks, but I hope to be back more active in the near future. So I would still like to be a part of the AVHD project.
Thank you. I'll just send an email to Kwan then.
Okay, great.
Okay, so that's it from my side on AVHD, and Shell and Margaret, you have the floor.
From my side, I can't make a decision in the meeting live. I really have to go offline to answer this question. Like, I'll be there to support the project, but I don't even know what being a vice chair means, and hard for me to commit in the moment.
Okay. Do you talk to Shahid about it, or do you want to talk to me or Margaret, or your company?
I think either is fine.
So I mean I can stay on a few minutes afterwards if you want to talk about it with me.
Sure. I mean, I think we can speak for a few minutes here.
Rohit, you want me to stay also in that call, or it's mainly with the VQEG chairs you want to talk?
You could also be in the call, yeah.
Okay, thank you. So I think we reached the end of the session for today. Should we go through the minutes and approve them before we end?
Yes.
So let me screen. Okay, I guess you can see my screen now. I think we did the project update. There were no decisions there. So, but if you find anything that is not correct, you can tell me. We can update, or you can update it yourself. JEG hybrid went on afterwards, and there were 2 presentations. No decisions. Okay, then we had the AVHD, and now we actually have some decisions, but we don't have any no text. So what did we decide? Decided to add Wise AVHD if Quan I may have missed something there. Please, if someone knows if the spelling is right for Quan's last name, is still.
So one question to Margaret. Margaret, I think because now the sessions are recorded, we do not have this formal requirement of writing down the minutes of the meeting or discussion points, right? I mean, one can always refer to the video.
I agree. Decision points are the most critical.
Okay.
Everything else is really optional, and you're right. We can always refer to this recording, which will be made available online. And I would like to remind people you can't get to the FTP site through your browser. You're going to have to use an FTP utility like WinSCP.
Mm-hmm. Yeah.
Oh, and the June 21st meeting for AVHD is on the VQEG website. I just missed it looking at the website. So that's already, the connection information is already available.
Nice.
This. And there was some was it Johnny that was suggested for the other, or was it Facebook person in general?
I mean, at this point, I don't think the group can authorize just a general name. So you can put tentatively, I mean, provisionally my name. And during the next call, when we're going to be discussing, if there is an appropriate person who's going to be brought up, and essentially maybe authorize the group, the members that are working on the live QA project to, you know, maybe ratify if it's going to be me or maybe someone else from Facebook at that point. Is that okay?
I think that's okay and very reasonable. Yep. And the same for Rohit, that it's tentative till we discuss with him, and then it will be either confirmed or at his discretion. We'll leave that open.
No. Okay, does it cover what we said, or should we? Yeah.
I guess Shelley, you will propose the time for that offline discussion, right?
For Rohit, I think it's immediately after now the session, and I guess Jan need to take a discussion at Facebook first.
Yes, I would propose we stop the recording though,